Hello everyone. Let's look at a case study on MLOps for visual pollution detection. So visual pollution detection is basically when you detect pollution in a street, for example, garbage or broken signal. You have looked at this template in the last video. If you haven't, please click below. We'll first understand what do you need to make sure when you are doing a project scoping. So project scoping brings a lot of clarity in the project. So first you would define the scope of the project. For example, how many elements you need to detect. For example, you will detect garbage, you will detect broken signals, you would detect construction on road, etc. Then you will understand how to solve, what kind of task you need to use to solve this problem. So this problem can be solved in two ways, right? So you have an image, you might want to do something like a multi-class classification where you identify a garbage and a broken signal in an image, or you need to exactly point out where the garbage is. Then you would do a object detection where you create a bounding boxes and then label this is a garbage or a broken signal. So imagine you have a data set like this, and then once you identify an object, considering we have going through an object detection problem, so you would create a bounding box here, like shown here. Then it's really important to create a metric. There are two ways to create a metric. One is your model metric, and one is your business metric. Right? So a model metric could be an accuracy, while a business metric could be a click-through rate if you are doing an online advertisement. So it really depends upon what your business needs and how you would evaluate a model. It's really important to combine both of these and come up with a common metric. So a metric could be accuracy, it could be something like a precision. If you have like a lot of data, it either could be latency and throughput as well, because you want to deploy this model into an edge device. And also you should estimate the resources and timeline to complete this project. Let's look at what are the things you need to consider when you are dealing with data. So the first and foremost thing is to collect an accurate data. When we say accurate, it should represent a real-time scenario. Then there is always a challenge where you have to annotate a lot of data in a large volume, and this question always comes: how much data you should label? There's no definite answer to this, but then there are some methods where you can annotate this data at scale. Something called as a weak supervision or active learning. And we'll look into both of these in upcoming videos. Other thing you need to consider is label consistency. So imagine a image like this. Now it is possible that some of your labelers might label like this. So there's a garbage everywhere, so you might label like this, or you might label like this. So they're small bounding boxes. One of your labelers might want to label all of these as a single garbage, right? Or there is a possibility that one of your labeler might want to create bounding boxes like this so that it covers all of these garbage. Now all of these three methods are fine as long as you are consistent in your labeling process. So it's really important to create annotation guidelines. for your laborers to annotate with consistency. So if you do not have a consistent label in your data, it tends to not increase the accuracy. So let's look at the remaining part of modeling and deployment in the next video.